Alright, so this is the key to worksheet 1.5 part 4, and on this worksheet you're dealing with quadratic functions, and there are certain methods that you are to solve each one. So in the first one, you want to solve this quadratic equation by using the square root property. And notice this is quadratic because you either FOIL this, 3x minus 1 times 3x minus 1, you would get quadratic. The leading term would be 9x squared because 3x times 3x is 9x squared, so it makes it quadratic. But remember, when it's in the form some expression squared equal a constant, then you can use the square root property. And so when using the square root property, you're going to take the square root of both sides. So you're going to say square root with a plus or minus. All right, so when you take the square root of both sides, remember you get plus or minus on this side. Now, the square and the square root undo each other. So on the left side, you're left with the expression 3x minus 1. On the right side, you're going to get plus or minus, and the square root of a negative 125 is 5i. So you're going to end up with two imaginary solutions. So these are going to be imaginary solutions. So these complex numbers are imaginary. And so to get the variable x by itself, you're going to add 1 to both sides. And so when you combine like terms, negative 1 and 1 is 0. So you get 3x equal 1 plus or minus 5i. 1 plus or minus 5i. All right, now since you're just dealing with imaginary solutions, then all you need to do is just divide both sides by 3, just like this. And then 3 divided by 3 is 1. 1 times x is x, and so that's your solution. So x would equal 1 plus or minus 5i divided by 3. And you can't simplify each of these terms. So 1, 5, and 3, the only number that 1, 5, and 3 have in common is 1. Now if you want to, you can write it, in a math lab you will, you can write it in the form 1/3 plus 5i over 3, comma, 1/3 minus 5i divided by 3. So that's another way to write the answer, the solution. Or you could have just said 1 plus 5i divided by 3. Notice all that's divided by 3, comma, 1 minus 5i divided by 3. So those are all different ways of writing the solution. Okay, number 2. Again, you want to use the square root property, but remember, in order to use the square root property, it's got to be in this form. Some expression squared equal a constant, and that number in front of that parentheses right here needs to be a 1. And so you don't quite have this in that form. Okay, so what you're going to do first, though, is you're going to add 14 to both sides. So I'm going to add 14 to both sides. So right now I'm subtracting 14. The opposite is to add 14. And so when I combine like terms, I'm going to get 2 times x plus 3 squared equal 14. Okay, now don't make the mistake and distribute. You cannot distribute here because the only time you can distribute is if this expression is being raised to the first power. That expression is being raised to the second power. So don't say 2x plus 6. So you cannot distribute. That has to be an expression raised to the first power. But what you want to do next, though, is you notice that this expression is being squared is being multiplied by 2. So you want to divide by 2. So you can divide both sides by 2, just like this. 2 divided by 2 is 1. And so you get, I'm going to put that here. So you're going to get x plus 3 squared equal, and then 14 divided by 2 is 7. Now that looks like this, which is like the original problem here. Okay, so now we're going to take the square root of both sides. I'm going to rewrite this. I'm going to take the square root of both sides, but remember, when you take the square root of both sides, you can get plus or minus on this side. And so the square and the square root undo each other, so you get x plus 3 equal plus or minus the square root of 7. Now I cannot simplify the square root of 7, because the only perfect square that goes into 7 is 1. So, and 7 is not a perfect square. So what I'm going to get here are going to be irrational solutions. Irrational solutions. That's what I end up with. And so when writing your solutions, you can write it just like we did the imaginary solutions here. So I'm going to subtract 3 from both sides, and then combine like terms. So I'm going to get x equal negative 3 plus or minus the square root of 7. And that's all you can do. So negative 3 plus or minus the square root of 7. Now you can also write your answer as 2 separate solutions. So negative 3 minus the square root of 7, negative 3 plus the square root of 7. Okay? Alright, number 3, you want to solve this using the quadratic formula. And so remember the quadratic formula, since we're dealing with x, is going to be x equal the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Alright, now remember b squared minus 2ac, that's called the discriminant. That's called the discriminant. But you want to find the solutions here. So you're going to have to substitute values from here into here. Alright, now before you determine what a, b, and c are, you need to write this in general form. So put in general form. Now some textbooks will use the phrase standard form. So basically all you're doing is writing in the form ax squared plus bx plus c equals 0. So that's the form of a quadratic equation. This is in general form or standard form. Okay, now, so to do that, I'm going to have to add 17 to both sides. I'm going to get x squared plus 8x plus 17 equal 0. That's what I end up with. Okay, now, a in this case, before you substitute, it's a good idea to determine what a, b, and c are. So a is the coefficient of x squared, which is 1. b is the coefficient of x, which is a positive 8. And c is your constant, which is a positive 17. So that's a, b, and c. Now, we're going to take these values, we're going to plug it back into the formula, and then use a calculator if you need to simplify the discriminant. Alright, so I'm going to get, the solutions will be x equal the opposite of b. Well, b in this case is 8, so the opposite of 8 is negative 8, plus or minus the square root of, and then the discriminant. So I'm going to put all these in parentheses. So b is 8. Now the parentheses can be very helpful if any of these were negative. So put them in parentheses. So in parentheses I'm going to put 8, that's being squared, minus 4 times in parentheses a, which is 1, times in parentheses c, which is 17, divided by 2 times a, and a is 1. Alright, I'm going to go ahead and simplify the discriminant. So I'm going to equal negative 8 plus or minus the square root of 8 squared is 64, minus, and then 4 times 1 times 17. So 4 times 17 is going to be 68. Okay? All divided by 2. So I'm going to get negative 8 plus or minus the square root of, now 64 minus 68 is a negative 4 divided by 2. Alright, now let's simplify the square root of negative 4. So the square root of negative 4 is going to be 2i. So that's negative 8 plus or minus 2i divided by 2. And then let's just go ahead and simplify this, because you know that negative 8, 2, and 2, I'm going to go ahead and rewrite this so I can tell you what I'm talking about. So if I were to look at these numbers right here, so all three are divisible by 2. So go ahead and simplify this. So we're going to get, right here, we're going to get negative 8 divided by 2 is a negative 4, plus or minus 2 divided by 2 is 1, so that's just 1i over 1. 2 divided by 2 is 1. But anything divided by 1 is that thing. So this numerator divided by 1 is still just the numerator. So that's going to become negative 4 plus or minus I. Now if you want to, you can also write it as 2 separate solutions, negative 4 plus I comma, -4 minus I. So you're going to end up with imaginary solutions. And notice that these are conjugates of each other. So one of the things you're going to talk about in a future section is that um, in terms of quadratic equations, quadratic functions, that the roots, if they're imaginary, occur in conjugates. So these are conjugate pairs. All right, so that's the end of the key to worksheet point 4, worksheet part 4.